Then precoding. So we saw the word precoding when we were talking about single carrier frequency SCFDMA, where single carrier was nothing but precoding before OFDMA. But you can do something else with precoding. What you can do is, when you have a data, you can put some reference signal on the data. That means this is exclusive OR symbol. So the exclusive OR with CRS. CRS is the cell reference signal. Okay, and then you transmit it. At the other end, you will remove the reference signal, and then you will get the data. All right. So why you do that? Basically, to make this transmission more random. Because if the transmission is all zeros, it will have disaster, because all zero could mean low values all the time, which would not be good. So you make it more like this, which is much better than all one level. So anyway, so there are two kinds of CRS: codebook based and non-codebook based. Codebook based means there is a formula. Non-codebook based means the modulation reference signals are added before precoding, and receiver can infer precoding from the pilots. So this one basically comes from the pilot, non-codebook, and codebook means there is somewhere a table. There is a table that is called codebook. Okay, and another difference is whether it is done before or after this box. In this case, this is done after precoding, and this one is done before precoding. The signal is added before this. So so this is it says are added before precoding. So this is before precoding. This is the non-codebook based. And so at this point, all you have is the pilot signals, and you just somehow add the pilots, and you get whatever you need to do after that. Anyway, so this one basically, the key function here is to randomize the signal, either way, to coordinated multi-point operation. And this is to basically, this is called COMP or COMP. And COMP's function is to do the interference reduction. Not the noise, but the interference reduction. So here is the problem. You are in a cell, which is, and the cell boundary of red and blue, this cell, this is getting signals from both, and almost equal signals from both. There will be a lot of interference at the boundary. We are using the same frequency. Right? So what do? We tell the other guy that, look, I am taking care of this guy. Can you please not do this? So I will talk to him at this time. During that time, please don't transmit in that direction. Okay, that is called coordinated multi-point operation. Okay, so now let's see more detail. So to improve performance at the cell edge, base stations coordinate transmission and reception. Joint transmission, multiple transmitters in the same subframe, dynamic point selection. So now here is another thing they could do. They could say that we want to sell this packet, I want to sell this packet to this guy, and can you please also send the same packet to the same guy. Okay, so they are joint transmission. Two base stations are transmitting the same signal to the same unit. So that we interfering there somehow, it is getting two copies, and somehow able to distinguish between the two copies and make all the corrections and errors and so on and so forth, and get better reception. So that is one way, right? Joint transmission, multiple transmitters in the same subframe. Now remember, the frames are all coordinated. They are 1 millisecond subframe, and if the clocks are synchronized, then I will say, okay, on the 5th subframe I'm going to send it, you also send it in the 5th subframe. Okay, things like that. Dynamic point selection. Transmission is scheduled from one base station. So dynamic point selection, basically this means that you don't worry about it. I mean, I will do your scheduling for the 5th frame, because I'm going to do 5th frame for this guy, and I will schedule yours also. So that is another way, is that transmission is scheduled from one base station. So one base station takes charges for both for that subframe, not for everything else. Joint reception, and then same thing. The base station, the mobile transmits. It goes in both directions. Both of them receive it, and both of them then send to each other. Okay, so basically, if you have any MIMO kind of thing, then you can clearly distinguish between the directions, right? So you can see that this signal is coming from here, this signal is coming from here, right? And then you can decode them separately, and then you can do error correction, just like we talked about in the HARQ and ARQ and HARQ. Joint reception, joint transmission, point selection, and UE is informed about different UL-DL decisions. So whatever you are doing, you tell the UE that this is what we decided to do. You are the boundary. Now you are in charge of, you have two bosses in charge. Listen to him, listen to me.
That's in case.
Eh?
That in case that the UA is fixed.
No, so it cares. No, it cares. I mean, if you are category 8, maybe you can do this. If you are category 1, you cannot do it. So it does care what the UE has the capability or not. That is the first thing we check.
No, I mean for the mobile UE.
So?
How would they know that it will be at this location?
Oh, okay. The question is, how do they know where the location is?
No, I mean, it's a predefined that at time frame 5 I will send to this.
Yeah, all this is done. See, this is one thing, it's very complicated. Yeah, but it is done in the sense that every millisecond they decide who will talk in the next millisecond. So it's not set up like before in GSM or something where you got the 5th channel and you have that 5th channel for 10 seconds or 10 minutes. Right? Here, every millisecond they decide who will speak and which carriers they will speak on and which half time, because a slot is half millisecond. There are 2 slots in a frame. Right? And there are 1024 subcarriers, and you get only 12 or some multiple of 12. So there are lots of decisions to be made about who will speak. But all of this is done at the speed of light, and so you don't see it, but this is happening. And as soon as the mobile hears that I have gotten the carrier from 15 to 23 or whatever, it just gets ready for that. It does the calculation and transmits on those carriers. So everything is very dynamic. So UE is informed about the different UL-DL decisions and about who is going to transmit. But this is called COMP, Coordinated Multi-Point Operation. And this is also actually, it doesn't say on this slide, but this is also helpful for broadcast. If we want to broadcast anything, we want to give it to everybody, then obviously both the channels will say, okay, like on the 5th frame we will do the broadcast, and they will broadcast. If it is a TV, if it is burning, it is anything, everybody will receive everywhere. But here we are talking about at the cell edge, how do you improve the interference? Alright, I think one point to emphasize is by looking at this figure, that what this is saying is that these are little things, are slots or frames or whatever you want to call it, subframes. And in each subframe there is, alright, okay, this is red, and this is blue, right? In this case, the scheduling is slightly different. In this case, they divide the whole frame. So they say, okay, like, first 2 frames are subframes are yours, next 2 are mine, and so on and so forth. So they can do, that way too. They could just multiplex on the time or share the time. Yeah.
Could you explain the joint reception? How would that work?
Joint transmission?
No, joint reception.
Joint reception. Multiple BS receive the signal from one UE and combine. Okay, so all these E and Bs are connected in the back, right? Right, so they can hear each other. They actually talk to each other quite a bit because of the handover on the back hall. Okay, so joint reception, you just change these arrows to the other direction. So they will both receive the same transmission.
But the UE will send one time or multiple times. How many times can it send the same signal?
And both are possibilities. Both are possibilities. I mean, the UE could be directional, in which case it has to send 2 in 2 directions, or it could be omnidirectional, in which case it will go anyway, both directions. So somehow both will receive it, and then they will compare the notes in the back hall, in the background.
I didn't understand how UAE can send multiple signals.
Yeah, right. So multiple signals two ways, right? Two is like two transmission and one is one transmission. And the answer is both possibilities. Yeah, you have a question?
So for the joint transmission, I think that okay. So for the joint transmission, the transmitters here, by the transmitter, the transmitter here, you mean the multiple UEs or multiple BS?
BS. Okay.
I think
Okay. So here when we said, okay, hold on.
BS.
Okay, hold on. Multiple BS receive. Okay. Here multiple BS transmit. So there. So we talked both directions, right? In the downlink and the uplink. Here it clearly is multiple. The transmitter is the UE. And the next question was asked, is that one transmission or two transmission? Basically, if the E and B are smart enough, they could schedule in one subframe and say, okay, just make one transmitter. So that's why this is coordination, right? So they could schedule you in that subframe and then you transmit, it goes both directions. You cannot speak to a base station unless they schedule you, right? So if they don't do that, then they will say, okay, all right, on one frame 1 you transmit me, and then on frame 3 transmit to that base station. So everything is coordinated. Yeah.
In the joint transmission, if the two BS can transmit the same data to the UE, so they should get the same data from
From the back hall.
So
Yeah. That happens too.
Yeah.
Yeah. See, the thing is, because they all have connection in the back hall to some MSC or whatever we call it, main switching center or something, right? So the data can go two ways from MSC to two towers. Generally it does, because the handover it needs to be done anyway. So when you are at the edge, the data starts going to both directions. You may not be able to listen to the next tower, but the data is there. And as you go and then you give up this tower and take that tower, your data doesn't get lost because it is at both places. It's very complicated. I mean, compared to IP is very simple. I mean, there everything was what we call distributed. Here everything is centralized. Okay. So the main MSC or whatever, that is central unit that decides that which tower is in charge. The two towers are in charge or one tower is in charge, and then they talk to each other and they do this. Everything starts from the boss, goes down to the downwards, right? Whereas in routers can make independent decisions in IP, and so we are coming from IP world. We are the net heads, remember? And so our thinking is very different compared to bell heads. Okay.